In this part of the lecture, the time history, how the time history functions are made and how we can apply those time history functions on the structure will be discussed. Because at the end of the chapter, harmonic motion, which was a force which was a time dependent, and response, of course, will be a time dependent. So we can make a force a time history. For that, you need the basically response of the force or the function of the force, like it is a sine function, cosine function, or any other function like seismic loading. Initially, you can get an idea if you are not familiar with that. The steps are written in the book. You can get an idea from that. For you know how to make a time history function. So in the different books of the dynamics, for example, the one version of the Mario Paz also, which was an old version, the same problem that we solved in the for the frame where the force Ft was 200 sine of omega t. Omega was the function of the omega is basically the frequency of the machine or frequency of the force, this load which is acting on the lateral loading, and 200 is basically the magnitude or amplitude of the force, and t is now the varying time. So you vary the time, you get at the different values of this force. Why? Because the force is 200 sine of omega t, and just by varying the time you can get the time function. Now if you want to solve this problem in SAP, let's say the procedure is written here, but I will solve any other problem, maybe a 3D problem in a ETAP. But you can also solve this 2D same frame example in the SAP or ETAP. You have to develop, make a model first of all, and the mass and these properties are computed. If not, the amplitude is basically this 200, the coefficient of the force, and the different other values, the damping, and Ft is now the time function, and period of the force you have to compute that what is the time period, basically 1 second, 2 second. So period of the force is this one. So based on that you can develop the time steps. This is the total basically period of the force, the time period. So you can compute that how much time step you need for the that one period of vibration. Complete जो एक आपका time period है for complete set of one vibration, you can make a time step yourself. Now how you can compute this time history function? You have the function sine of omega t is the time history function. So now you can compute the time intervals. The 20 steps were computed, so starting with the 0 second, and every step is basically time over 20, time period over 20. You can have the step size, every step size. You add the time in that, and just compute from the calculator sine of omega t. So you can compute this sine of omega t, where omega is in radians for this case when you are solving the dynamic problems, and you can compute all the values of the sine omega t. Now the total force will be 200 multiplied by sine omega t. 200 you will apply on the directly on the building, and you will assign that force as a time history function. So this basically you have to make this function. This is the force is not included in that, but this is a sine function. So it means that at some instant that force will be multiplied with this value, at another time the force will be multiplied 0.58, at point, let's say with changing the time, when the time is changing, the force value is multiplied with a different factor. Sometimes the force is positive, sometimes the force is negative, and sometimes it is more, sometimes equal to the f naught, and sometime lesser than that. So every time the force is increasing and decreasing, and this becomes the time history function. So the step for the SAP is given. You install the SAP. You have to basically go to the model, and then you have to develop the model. And after developing the model, you have to set the restraint and everything. And then after that, you can define the material, frame sections, whatever the sections are given. You go to the time history function, dead load, live load, and you can assign some load there also, and you can click the apply that load also. Load, let's say the amplitude of the force you have to apply, and function you have to define. The function that will be defined, and the amplitude will be applied on the frame wherever this load is acting. And then you will define the time history function, and you will apply that function to that load. And there are the different parameters in the time history function. These parameters are the damping, time steps, factor, different your functions, and those are applied in the time history function. And then you can set the analyze and set the analysis options, and then you run that which case you want to run, and then output of is obtained at every time. You will obtain the different values, the outcome, giant displacement, but the time is also varying. So you can see the maximum displacement and time history function also. This displacement will be obtained in the as a function of the time. So response of the system can be seen, but just by watching the outcome. So let's apply any time history function general to any building. This is a structure. Any structural system you can go with that. So what will the procedure? You can understand that how the time history load is applied to any structure. Can you see the ETAP screen?
Yes, sir.
So you start with the file and the new model. You can set the units, metric system or any other system. A new window will be open. I'm making here the simple building because the time st function, it is basically not a regular one. So I'm taking it as a, let's say, number of grids are 2, making it a 3D model. But you can make it as a 2D model. Then you will take the one grid line in y direction or in x direction. One grid line in any direction you will take, depending that you want to make a 2D frame. But I am making, let's say, a 3D frame and with number of stories as, let's say, 2 or 3, and typical story height and the bottom story height is slightly more. So I have making it, you can customize the grid spacing, you can customize the story data also, and let's say I'm selecting the structural system as a two-way rift slab. So I select that. And you can apply some load here. The typical column beam slab is already defined in the system. Concrete beam, slab 1. These elements are by default given by the ETAB. And you can apply if there is some super dead load, let's say of 1 kilonewton, or you want to apply some live load of 2 kilonewton on per square meter on the building. And the bottom at the restraint at the bottom is, let's say, fixed. And the floor diaphragm rigidity, it means that the floor is moving as a whole, is a rigid floor diaphragm is considered. One time okay, and then second time okay. So a structural system is built. You can see here the 3-story structure with the beams are there and the columns are also there. And basically here I'm not explaining the detail about the material and making a frame section. That I will provide you some other recorded lecture for the ETAB making a model and ETAB handouts also, so that you can learn if some of the students are not already using it, and you can learn it how to use it, but it is not very much difficult. Now the point is that how to, mainly we are emphasizing on the how to apply the basically the time history load. That is the point, that what is the time history function, what is the time history load. And of course you can define the materials initially if you want to have some material property. You can add the material. Currently the concrete material is given as a 4000 psi. You can add also the sections. There are more sections also. You can add the other properties also. And then you can define the mass source. These are important. The time history function is important. But first it is important that which load we are applying. So let's say I define some load. Define the load pattern. So dead and live are already designed. You can apply the some new load. If you only want to see the results of the time history separate, so I am writing here as any kind of the load. Let's say machine load or the seismic load, and I am applying here the periodic load. So let's say I'm saying it as a TH, time history, periodic. Load, and the type of the load, it can be, let's say, a live type of load, and self-rate multiplier is 0 because I want to see the result separately. If you want to add the mass result in it, then it will be, of course, if you want to add the self-weight in that, you can make it 1. 1 mean that self-weight is added already the part of it. So I add this load, and I am not modifying this load as any autolater load or like that. Because it is a live load, not a seismic at the moment. I am making it a separate some time history load. Because currently you have not studied about the response spectra and those things, although the seismic loading you have studied, and I will tell you later about the seismic also. But initially I will apply some sinusoidal function on this building. So like a machine load was applied at any joint. So these are the different loads. The dead and live was already applied on the slab system, and I can see by clicking the slab system, just by right clicking, that what is the load actually on this slab. So this uniform load, dead is acting, live is also acting, but there is no any other load which is applied. Let's say I want to apply some, of course the load I can change also, but I will apply at the joint of the buildings, at joint of all the nodes in the x direction. This is x and y, and z is the direction along the height. I want to apply the load in the x direction, parallel to the x direction time history load. But for that, and under the periodic case, so you would have to define that what is your functions, the time history functions, because you have to first tell the computer that what is the function of that sine of omega t. Like I have shown you initially an example from the Mario Paz book, that the sine of omega t is a function, where omega is the function, omega is the frequency of the force. So here also I can define any, first of all the time history, and then I can apply any magnitude on these nodes. Those magnitude I will convert into the time history. Load will vary, and I will run the model analysis, the dynamic analysis also, and you will see that what is the result for the different cases. So first you will define the function time is response spectra, our next topic. So these are the functions that you apply in the seismic loading, dynamic loading, the response spectrum analysis is there, and the time history analysis is there. And further there are other types like the linear time history, non-linear time history analysis. You know the analysis are different: linear static analysis, non-linear static analysis, that is also called as a pushover analysis. Then is the linear time history analysis and non-linear time history analysis, response spectrum analysis. So there are many types of analysis, but history analysis, the advantage is there that you try and simulate the real loading, earthquake loading, any other loading which is varying with the time to the structure, and you see the response structure not at a maximum response only. You can see the response of the structure at different time steps. If you are giving 20 time step, you can see at all the seconds. If you are want to see the response at half of the second, it's up to you that what is the delta t value that you are giving in the time history. And you can see the peak also, that when the peak response occurs, this was the vibration applied to the building, and what was the instant that when the peak response occurs in the, you can see that by the time history analysis. So you go to the time history function. This is a time history function. Can you see the time history function window? Define time history function. Can you see on that window?
Yes, sir.
Yes. Now that there are the different functions like sine functions, you can add the new functions also, and like sine function, if you want to modify that, there is a one sine function. Some are the built-in function like cosine function, ramp function. We will also study the different the ramp function, triangular function in the today in the later part of the next part of our lecture. So, but generally sine function है तो you can modify that, you can add that. This is a sine function modify. ये ramp के साथ है. This is a ramp function. So you want to see the sine, you want to add that sine function, you have to add that. This is a sine function, you can name that function. Okay. And this was the basically you can change these values from that I was showing you, that at any time instant, number of time step you already know, you want to these are the values which are basically already given. Sine into omega t, sine omega basically t is the time which is on the first column, omega is the frequency of the system which is already known, frequency of the force, and t is the varying. So sine omega t is computed. So sine theta basically, but theta here is omega t. You must know the frequency of the machine or frequency of the applied force, which is not known for the earthquake. It is different, but for the machine load, regular periodic load है ना, तो उसके लिए आपको पता होता है. So in that case you will now compute the लेट्स से साइन फंक्शन में ऐड कर रहा हूँ, इससे मैं कह रहा हूँ टाइम हिस्ट्री फंक्शन, टी एच फंक्शन जो है इसको मैं आई एम लेट्स से गिविंग अ 20 number of steps, number of cycles are let's say 5 cycles हैं, and period is of this is let's say about 2 second कर ले. ये डिफरेंट जो है वो इसकी वैल्यूज होंगी. Currently, I'm not changing any function, but let's say I'm telling you about this function. And name is a time history function, and this is the number of time steps are 20. So if the total period is 2, so there are the different 10 will be the total, because the time steps are now 20. So you set this function as a time history function and you add the new function, and that will be added here. Now, if you want to say that you want to add some seismic factors, so I can tell you here briefly, but when we will study also the response spectra, because there is a one software which will be used, and maybe in the later some lecture I will explain about the seismo match. You match the, you want to see the peak response and you want to apply some seismic loading, तो वो फैक्टर भी मैं हम डिफाइन कर देते हैं. ये बाकी जो फंक्शन है मैच टू द रेस्पॉन्स स्पेक्ट्रा जैसे आ जाता है ना ये, or you can add the new function. Click on the add function, or here are some functions are available in the new EA installed. Some from the file. I'm not sure whether it is available in the file or not, but there is a, you have to pick any data file from the time history file that should be available with you, and you can take the function from there, or you can go with the seismo match spectra, like match to the seismo response spectra, and then you click on the add new function, and this is the time history function. This is a program default function. Target response spectra is given, but you have not studied this topic yet. And you match the time history from the multiple response spectra. So there is software also which can give us this function. This time history is, this is the related to the seismic time history. The time history that I am applying is a regular periodic, but here you can see the seismic loading which is highly varying, and this is also a time history. What is a time history? At x-axis is the time, at y-axis is the acceleration or velocity. It is a displacement or velocity or acceleration. So at for one earthquake, there are the specific time history for certain time period. This is recorded by the seismic measuring instrument. I told you that they are recording these values. Basically, this response spectra is a result of multiple time histories. You pick the peak displacement for different time period. This is the response spectra. So normally, the time history analysis is basically analysis in which you apply the load which is varying at the time, and in response spectra, you see the peak response. You want to get the peak response of the building. Basically, response spectra is something different. This is not exactly the load, but the peak response of the building at different time periods. And the time history is basically the graph at time versus the response. That basically is the actual, the recorded load that is represented by the time history, and the peak response is given by the response spectra. तो इस तरह हम वो time history वाला भी add कर सकते हैं. But let's say I'm currently adding the time history function and I define it. I say okay, the time history function is defined, and the response spectra we have not studied yet, but that can also be defined. Now I say that what are the different model cases, different model eigen values हैं, या इसमें आप चेंज कर सकते हैं model. Basically there are two types and you can give the eigen model cases. What are the number of modes आप set कर लें, कितने modes में आप इस building को vibrate करना चाहते हैं. There are the different modes of vibrations. एंड आइगन है और इसके अंदर रिट्स है. ये दो मेथड्स होते हैं. mass source जो है that is basically the mass source is a dead weight of the. There is a mass on every story. Definitely it is to be defined first. I will explain it now. And P delta effect लेने हैं नहीं लेने at the moment, not taking any P delta effect, number of modes and convergence tolerance. These are the cycles per second. Frequency shift is normally by default it is given as 0, and minimum number of modes is 1, maximum are 12. So these are the modal setting for the because we are doing the dynamic analysis for the different modes of vibrations. You can set the mass source because the mass source is basically the lumped mass approach or any other. What is the mass that you are considering? Normally the dead load is considered as the mass source, and I can modify this mass source because only the dead load is considered, including the element self mass and additional mass, whatever. You can only give the specified load pattern, and you say that okay, the dead load multiplied with 1 is the mass source. I select the mass source from the dead load pattern. Now the cases, this is important, that what is the load cases you want to apply. So I go to define the load cases. So I say that the dead load run by the time linear static, live also linear static, because I am mainly interested into the periodic load result. So I click on the periodic load, and now I set it. I say that run it as a time history analysis. This is selected. Linear model. There are different types: linear model, non-linear model, linear direct integration, and the non-linear. So linear dynamic analysis is the linear model analysis. So mass source is given as a previous mass source. Load pattern. Normally the scale factor is given when the ground acceleration G value यहाँ use करते हैं, जब earthquake का होता है ना scale factor. So load name is a periodic. Function is basically I have to tell which function was defined as the TH function. The time history function was defined, and the periodic load is there. This is a periodic load, yes, and the load pattern and time history scale factor. Model load case is a model, and there are the time history motion will be a transient or periodic. So this I can select as a, let's say, periodic. Number of the output time steps is how much output time step I want to take. These were about the 20 steps. And output time size 0.1 second. Modal damping is constant. 5% damping ले लें या कम ले लें. You can modify it also. What was our time step size? यहाँ हम ज़्यादा भी ले सकते हैं outcome, because that was an input. You can have the different also. This is the time history that you are applying on the structure. Functions, all values are defined for the time history. Then you click OK, and then second time OK. हमारा जो function था TH function, जो है sinusoidal type of function. It is like that. Now next part will be the load cases are defined also, and actually the load is still not applied. The amplitude of the force, that will be a time history force. Let's say it is a 100 kilonewton or let's say 200 kilonewton is applied, or you can change the force also. But I want to apply this force. You can apply anywhere: lateral direction force, vertical force, periodic force. Basically, it is told by the when you install any machinery. Or for seismic load, it is a lateral direction. Normally, the dynamic load is affecting a lateral direction in the building. But you can, it's up to the case that how the machine is installed, what is the direction of the force. So define menu is there. I will check the I will apply the load in the x parallel to the x direction. So let's say here I apply some value. I first clear all the selection and I only select these two joints, joint number at story number 3, and I assign the some force. I say the frame load is a point load, and in global x direction, giant load. So close it, assign the giant load, and force I will apply to the giant in the global x direction. Let's say I say the force acting here is a 200 kilonewton force, and I say this is a not the case of the dead end live, but periodic load में मैंने इसको ले लिया. So I say add to the existing load and I click on the apply in the x direction. So you can see now that the load is applied in the at the top nodes. Now I say that at second story also there is a periodic load, and giant I force and I apply the load only at the second story, periodic load. Similarly, I say there is a periodic load at the first story also. So I go to the assign menu and I go to the giant load and force. And I see a periodic load of 50. So all these force will become the 50 times the time history function. Top story पे होगा 200 times the time history function. At the first floor, the 100 times the time history function. All the loading is applied now in the x direction. Now this load is not, if you apply this load without a function, now I put this load under the heading of the periodic force. So this force will automatically will not be applied only once, like you are doing the static analysis जैसे आप करते हैं, you just apply the load and get the result. But now this force has become the function of the time because I apply this force as a function of the periodic loading. Therefore, the force will vary with time. Now you can see the analyze it, check the analysis model also. I have assigned the load if you want to assign any other load. But first you can check the model, whether is there any error in the model or not. If there is error or minor issues of the stiffness losses, you can trim or extend the frame and move the joints to fix the problem. So the message will appear here that the bottom restraints are hinged. You can play with the different things by changing the bottom restraint, by adding the shear wall things when you will apply the time history earthquake function. So that's why these things are important whenever you are analyzing any building which is basically uh, in the high seismic zone. You should analyze it as a time history. The time history of the Pakistani earthquake record should be obtained, and then that should be applied. And you can check the peak response of the structure and peak displacement also, because there are certain guidelines given for the displacement. So whenever you are doing some performance based design for the structures, then you need this method of analysis. So there is no warning message. The model has been checked. You can analyze for just to save the time. You can set the load cases to run, because I am only at the moment interested in the analyzing the for the time history. So set the load cases to run, and now you will go to the model. Yes, periodic, yes, and I say not for do not run for the dead end live load, because at the moment I'm only interested in the dynamic output. And then you can analyze the model. So now you can see the results. Here you will see the results and you see that the period is also given. The time period जो है ना, because in the mode number 1 this is the time period. So basically this is in the mode number 1, the is normally considered as the critical mode, and you can see the behavior of this force. That force which was applied as a time history force. Here you can see the load and the deformation of the building due to this application of the model load. Now, what is the displacement? You can click on the joint. The displacement is about very small, but it's still there. Okay, and you can see the different for this mode. There are different modes. Here from this bottom arrows are marked, so I can show you the deformation for different modes. Mode number 2, mode number 3, mode number 4, mode number 5. पीरियड आप पढ़ते जाएं, किस में पीरियड ज़्यादा था, टाइम पीरियड. मोड नंबर 1 में आपका 0.386 था. ऊपर आपका यू कैन सी एट द टॉप ऑफ दिस विंडो, नॉट होल विंडो बट जस्ट in on this top, what is the time period. This is the mode number 9. This is the time period. Mode number 1, mode number 2, 3, 4, 5, 6. Can you see the different modal shape on your screen?
Yes, sir.
This is a mode number 9. So this basically the different modes, linear modes are there for the building, and you can see that the building can actually vibrate in the different scenarios. And the point is that which mode is utilizing our core mass, that mode is the most effective, and that will be most economical. Now this was the model, different modes, behavior of the structure for the different modes, dynamic and outcome. But now we want to see the for any mode. Let's say mode number 1 कह लें आप. You want to display the base reaction कह लें, या you want to see the deformed shape. Deformed shape अगर आप बात करें. And now I am interesting not in the mode, but I am interesting in the case periodic load और time होगा, यानी कि different time पे अब आप periodic load at 1 second 1 से शुरू किया था, फिर 1.0 से. At every 0.1 second interval, you can see its behavior. जिस टाइम पे भी आप करेंगे वो नीचे से आप you can scroll it and see the deformation of the structure. And I now click on the apply and then OK. Now I will see this one. अब आप ये सारे स्टेप्स का डिस्प्लेसमेंट डिफरेंट स्टेप्स के हैं, 20 मैंने रखे थे ना, ये सारे स्टेप्स का डिस्प्लेसमेंट 18 स्टेप्स, 17 में 16 में कितने मिलीमीटर. यू कैन चेक, यू कैन प्लॉट द फंक्शन आल्सो, लेकिन ये हर स्टेप का है. दिस इज एट 11 स्टेप, 10 नंबर स्टेप. आप इस पॉइंट पे आपका जो है, so you can see the displacement for ये अब 57 आया है, 6 स्टेप में ज़्यादा था. I was checking for that certain mode that was very less, लेकिन ये अब आप देखें कि किस, so at any time instant जो है that displacement can be maximum. So this is the displacement of the structure. Basically अब जब when the structure is vibrating at any time instant it can maximum. Now I will see the I will show the story response plot. अब आप देखेंगे कि टाइम के साथ these are the maximum displacement, ये उसके आए हैं that both the direction x and y are shear due to these load. What is the value of the shear varies. ये मोड नंबर 1 के लिए the story displacement आ गई. This is the story drift, this is the story drift. So you can see the story response plot. Now you can see the plot functions. अभी तो हमारे पास you can see the plot function also, the base reactions है, ये आपका plot है. Now this is the base का जो fx है, the force developed at the base. You see that you are getting the one result when you are doing the linear static analysis. And here I can scroll it down. मेरा different इस point पे when at out of the 2 second का मेरा एक vibration था, and at which second I get the maximum response, 0.5 second, because it is a regular sinusoidal load. So you can apply this at the different instant. You can apply this load. Can you see that very graph on the screen? This is the outcome of the force. Can you see that? At which point the peak response occur? Hello?
Yes, sir.
This is the response of the basically the force, the reaction that is developed at the base of the building. And definitely this is for the first mode. For the different case, you can have the different response for all the modes. And time history is, this is the time history that the result is not a single value, but in forms of curves you get the result. This was a sinusoidal application, so the answer, the building also show the sinusoidal response. And you can plot the different function, you can get the result, you can display the result, display the tables also. And response spectrum curve भी आप ले सकते हैं कि आपकी different time periods पे building क्या इसका behavior है, building का response क्या है. This is the response of the building कि डिफरेंट डैम्पिंग के लिए फॉर द डिफरेंट डैम्पिंग वैल्यू आप देखें कि फॉर द रेड कलर इज 0 डैम्पिंग 0.02 that I have shown you this pseudospectral acceleration response in the harmonic loading chapter. So for the different time period जो है आप देख सकते हैं कि इस बिल्डिंग का हमें टाइम पीरियड अब क्या रखना चाहिए, इसका जो रिस्पांस है दैट इज बेसिकली इसमें हम जो है वो डिस्प्लेसमेंट रिस्पांस भी ले, वेलोसिटी है, एंड दिस इज द स्पेक्ट्रल डिस्प्लेसमेंट रिस्पांस है. This is the spectral displacement response. This is the velocity response, pseudo velocity response. This is the pseudo acceleration response. बिल्डिंग यानी कि डिफरेंट अगर इसका बिल्डिंग का टाइम पीरियड हो तो उसका पीक वैल्यू क्या आएगी. रिस्पांस मैंने बताया था आपको, रिस्पांस स्पेक्ट्रम कर्व आर गिविंग अस द पीक रिस्पांस ऑफ द स्ट्रक्चर एट डिफरेंट टाइम पीरियड्स. तो इसमें आप देख सकते हैं कि व्हाट विल बी द अबाउट 2 टाइम पीरियड के पे हमारा पीक रिस्पांस आ रहा है अगर हमारी बिल्डिंग का जो है वो इसमें, और डिफरेंट डैम्पिंग एज द डैम्पिंग इज इंक्रीजिंग द रिस्पांस इज आल्सो decreasing. So in this way you can see the plot the different curves and the plot functions जो है आप different ले सकते हैं. पीरियाडिक लोड टाइम हिस्ट्री प्लॉट, इसमें अभी हमारे पास जो बेस की फोर्स है यू कैन सी दैट व्हाट इज द हाउ द बेस शीयर जैसे आप निकालते हैं ना कि इस बिल्डिंग की किस पॉइंट पे आई है. तो आई एम गेटिंग द 750 किलो न्यूटन बेस शीयर एट द 0.5 सेकंड पे जाके आ रही है, उसके बाद फिर वो 1.6 सेकंड पर जाकर आ रही है. सो इन दिस वे आप इसकी टाइम हिस्ट्री चेंज करें, बिल्डिंग की सीज्मिक लोड अप्लाई करें तो यू कैन सी द रिस्पांस अंडर द सीज्मिक लोड. And you can see the results in the tables also, in the form of table also you can see the results, analysis results, time history functions. You can select the time history function, then the load cases, you can get the results of the time history model, which result you want to see, the reactions you want to see, base reactions. So whatever the result, story forces, you can get the result and the table will be built. Different tables, यहाँ पे बनेंगे. फॉर एग्जांपल दिस टेबल इज द पीरियाडिक लोड मैक्सिमम. ये कितना आ रहा है, ये मूवमेंट कितना आ रहा है बेस पर, और mg, ये 3 वैल्यूज आई हैं. fx, तो व्हेन fx इज प्रेजेंट my इज प्रेजेंट एंड mg इज प्रेजेंट. ये बेस रिएक्शन था. यू कैन सी द स्टोरी फोर्सेस, सारी आपकी vx आई हैं बिकॉज द लोड वाज इन x डायरेक्शन और ये ट्विस्टिंग मूवमेंट आया है. and my आया है, mx 0 है because the load is applied in x direction. So you can see a lot of results and you can play with the results, you can improve the results. अगर ज़्यादा है, you see the code, seismic code, and you see what is the peak response, and then you can apply some techniques to reduce that जो drift है, drift की limits है ना, आप basically you see the response and the drift plot and then you see that how you can reduce that, and you can see the different plots and you can reduce the drift also. Story response plot में maximum story displacement, maximum story drift भी आप देख सकते कि हमें कितनी drift अलाउ है. Drift is the ratio of the displacement to the height. Displacement is different, drift is different. आप एनर्जी देख सकते हैं कि what is the energy, energy basically the कि कैसे इस बिल्डिंग की एनर्जी कितनी. Here you can see the graph of energy. Can you see the graph of
Yes.
energy on screen?
Yes, sir.
Yes, here you can see the energy. ये मैं आपको भी बताऊंगा what is energy and energy absorbed, what is the energy which is inputted into the system and what is the energy output from the system. When the load is applied, the structure is moving, and when anything structure is moving, the work is done in that. Force into distance is the work done. So what is the applied loading and what was the outcome? So here you can see the kinetic energy, green line में potential energy, blue under the area under the curve है जी, blue में फिर उसके बाद the modal damping है, that is the damping viscous energy basically is utilized due to the damping and non-linear viscous damping the energy ये इसमें नहीं था, लीनियर हमारा केस था. ये तीनों आपको फर्स्ट 3 आर विजिबल. So this was the energy basically which is absorbed into the system and displaced in kilonewton meter. You see, at the zero displacement, the energy is minimum basically. And when the displacement is again increasing, so this was the behavior of the structure also, and accordingly, it is a positive way में यहाँ पे तक था, फिर negative displacement है तो this energy that remains always positive. So I hope that you understand the time history analysis and you will try to apply on the structures. So you have any question related to that?
ये एनर्जी स्पेक्ट्रम का बता दें कैसे आएगा.
एनर्जी एनर्जी का पूछा आपने.
जी सर.
You can click on the display menu and then you can click on the cumulative energy component. Okay. और अगर वर्चुअल वर्क आपने देखना है, फोर्स इनटू डेल्टा, द वर्चुअल वर्क डन, you click on the display and then you click on the जितना भी हर मोड का आप देख सकते हैं, ये आप इसमें ये इस पे स्ट्रक्चर पे देख सकते हैं that how much was the virtual work done. आप देखिए ना 88 मोर वर्चुअल वर्क कॉलम में जैसे ऊपर कम है, it is increasing in the bottom. This is the you can display the virtual work diagram on the structure also. So this was about the E-tab analysis. And these energies expressions I want to show you before taking a break. So there are the different energies in the structure. Here you can see the slide. Energy is basically in viscous damping जो होगी, that is the force, and input energy that is to the system is the force into displacement. जो first वाला है ना, ये energy की different expression यहाँ है. पहली आपको मैंने बताया कि force into displacement. So force is basically periodic load. This is the displacement. Du, you know, कि velocity, displacement into time. Velocity to time is displacement. So putting the values. ये first energy है input to the system. Putting all the values is not difficult. So next one is the energy which is dissipated by the system. अब dissipate कहाँ पर हो रही है? Damping के through, displacement के through, stiffness का component हो गया, mass के through, inertia. तो different units जो हैं, for example damping जो है, the damping force into displacement, damping क्या होती है? C into U dot and J displacement, putting the value. So this is the energy which is going through the damping. And then is the therefore the EI and is computed, EI जो है, and also the EI value that is equal to, ये इसका phase diagram था harmonic loading का, that was the vertical component, this is the horizontal component. So tangent J angle आ जाता है, sin phi will be equal to the sin phi is equal to the vertical over the hypotenuse. So this comes out to be this one. Phase angle भी आप निकाल सकते हैं. So energy which is an input to the system and energy in the which is a dissipated in the system जो है, ED जो है ना dissipated हुई है system में, that is equal. इसी तरह energy in the viscous damping जो है वो potential energy की बात करें तो potential energy कहाँ पे store हुई है? In form of spring जो है, stiffness. So Fs is the stiffness force, putting the value of the U and then solving it. This is the stiffness कि ये stiffness के लिए जो है वो energy है. The kinetic energy जो है, that is the per cycle due to the inertia में जो है, that is Fi into du, the inertia force into the displacement, and then displacement is equal to this one, ये inertia की force है. And when the beta is equal to 1, sin phi 1 हो जाता है, and EI will be equal to pi into P naught the force into omega, and ED जो है that is become this one, or for EI is equal to ED, you can say कि जो rho है amplitude, in that case when beta is 1, this is the amplitude which is the same relation. ये पहले भी हमने प्रूव किया है कि जब बीटा जब 1 होगा तो what is the amplitude is P naught over 2 xi k in case of the maximum value of the this is the maximum value of the response. तो ये आप अगर प्लॉट करें FD as a function of the U, you get this ellipse. Why? Because FD is there. FD है, ये Fi है, Fs है, and when you plot this force as a function of the U, so these forces basically the curve is giving you the work done also, force versus displacement. So which kind of curve is obtained? तो अगर इसको आप ऐसे simplify भी करें FD को, तो dividing by the rho square, you see that this curve is obtained, U over rho square plus FD over this square, and this is equal to 1, and this is the equation of ellipse. So ellipse is formed when you plot the FD versus U. And when you add the two energies, FD भी कर लें ऐड, उसमें स्प्रिंग वाली भी ऐड कर लें, तो you get this time of the ellipse again, but it is a basically inclined, rotated ellipse इसको कहते हैं. So this ellipse is formed when you plot the energy as a function of the U. So ellipses are formed. So this was about the energy dissipated. Our next part of the lecture will be the response to the general dynamic loading and transient response. This is the next topic, general dynamic loading and transient response of the structures.